out of sine, cosine, and tangent. So, Katoa, which ratio would you use? Don't say anything. Which ratio would you use to solve for y? Which ratio would you use? Okay, not to put anybody on the spot. Anybody, just say it, the whole class. I'm asking the whole class. Say it if you know it. What ratio would you use to find y? Sine. Okay? It should be pretty natural to say sine. Why? Because it would be the only unknown out of the three things you have. So we would use and say sine of the angle 65 degrees. Sine of 65 is opposite over the hypotenuse, which is going to be y over 10. And to get the y by itself, multiply both sides by 10. And you put that in a calculator, and you get y equals whatever, approximately what that is, no? Make sure if you come up, get a calculator, make sure it's in degrees if you want to get the answer to it. To the nearest what are we going to do? Give me an answer. Put it in a calculator. What is 10 times sine 65 degrees? Make sure it says degrees. It's okay. Somebody, anybody? Let's go. Okay. Here we get into the nearest what? 9.1, 9.1. So over there is 9.1 approximately. And we're going to use cosine 65 to find x over 10. Multiply both sides. And approximately x is going to be what? You can put that in the calculator, put it in your calculator, 10 times cosine 65. What is it? Hmm? 4.2? About 4.2? Okay, so 4.2. We left the easiest one for last. This is 90 degrees. 90 degrees. These two got to add up to 90. 65 plus. What is 90? You can look at it like that. 25. Yeah. We've solved the triangle. That's it. We've solved this right triangle. Okay, so now chapter or unit 8. I think this is going to be unit 8. Unit 8 is going to be the law of sines. And we're going to solve this triangle. The problem, the difference between this problem and the warm-up problem is that we don't have a 90-degree angle. So that's a problem. Yeah, we can't just go sine of 40 degrees is the opposite over this. We can't really do that because it's not 90. This right here is not 90. This is not 90. You got a problem. So we are going to come up with a formula or whatever it's called. It's called the law of sines. And this is how we're going to come up with it. Somewhere else, draw the same triangle, but this time we're not going to have the angle. So the angle 40 is 65, 10. We're just going to have it in general, some kind of angle and side, and so here. Make another triangle. Here, that's pretty much the same triangle. It is the same triangle. Where we're going to label the angles with capital letter A, and the one problem we had, it was 40 or something. Make another similar triangle where this is A. And I'll go back to saying that this is standard trigonometry where the angles are capitalized and the opposite side of A is going to be little a. And so somewhere else is going to be capital B angle B. Or I guess I go in with C up here, down here. So if this is C, then the opposite of capital C is little c. And the angle at the top is capital B. And the opposite of capital B. Okay, I guess I'm not even doing that. Okay, here we go. All right, so we don't care about capital B over there. So it is there. Capital B and opposite over here is little b. But here's how we're going to come up with the law of sines. This is, so far, this is true. We're going to draw an altitude and make two right triangles. That's what we're going to do. Draw the, it's called the altitude here. Yep, here we go. And so we got two triangles here. Out of one triangle, we made two triangles, two right triangles. So we draw this altitude here, and we got this triangle, right triangle here. And we got the other triangle over there, right triangle. That one and the other one. All right, you see it. All right, here we go. Let's go with what is the sine? Sine of angle A. Anybody? What is sine of angle A? H over C. Everybody, we're looking at this right triangle, and we just did opposite or hypotenuse, H over C. So this is going to be H over C. Now we're going to do the other one for C. So sine, let's just wait for a second. Let's do sine of angle C is what? What's sine of angle C? And that would be what triangle? Which triangle? Let me see. Which triangle is it? Let me make you see it. Is this? And that's the right triangle. So what sine of angle C? H over A. This is going to be H over A. Because this is talking about this C is this angle here, this one. H over A. So now we're going to make them equal each other. What is it that they have in common, these two equations? H. They both have H in common. So what I'm going to do is solve for H here. Let's solve for H here by timesing it by C. Both sides cancel. So H equals capital C over sine A. I mean capital C times sine of angle A. It's not capital C, my bad. It's a little c. It's a side. It's a little c times sine of capital A. C is small. And this one over here is going to be times about A here, little a. And this is little a. So then H is equal to A sine C. Now we have H equal to that, H equal to that. So we're going to equal that. So that's going to be C sine A is equal to what? C sine A equal what? A sine C. Okay, so now what I'm going to do is just this to get to what is recognized as the law of sines. I'm going to divide both sides by c over a, c, little c and little a. Little c and little, just it makes it faster, quicker. What we can do here is what? What can we do on the left side? Cancel out the c and the c, so now I'm left off with sine capital A over little a is going to equal 2. And what can we cancel here on the right? A and A. So now I have sine c, capital C over little c. So we got sine A over A equals sine C over little c. And just, what do you think is going to happen with B? Sine what? Sine B, capital B over what? Little b. Yes? It just follows that it would be true also, no? Yes? That is the law of sines. You can always flip it as the same, like any number you flip it. You could say B over sine B, A over sine A, C over sine C. It's the same kind of thing. It'll still be hold true. There it is. Okay, so this is called the law of sines. And we're gonna use that to solve any kind of what kind of triangle is this? All right, here. What kind of triangle is this? If you remember this from geometry, what were those triangles? Wasn't it like angle, side angle? You guys remember that from geometry? Angle, side angle? It's because you know the angle, you know the side and the angle. So this one is that you know the angle. No, we don't. Let's get it. Not this. Let's do one actually. Let's go back to the problem. Let's go back to the problem we just had. All right, let's go back to this problem. What kind of this is a what kind of triangle? This is we know the angle, so it's an angle, we know the side, angle, side, angle. So this is angle, side, angle, triangle. So law of sines solves angle, side, angle triangles. If this is capital A, if we call this capital A 40 degrees, this is little a, and if we call that capital B, this would be little b, and capital C, little c. Yeah, we can get capital C easily. Okay, just add these up, subtract it from 180. We can do that. Let's go for A. Let's go for A. Let me look for A. So it's going to be A over what? What's the formula? It's A over sine capital A, no? And what is capital A? Capital A is what? So it's going to be A over sine 40 degrees is equal to? Well, we do need to get this number. We got to get this number. What is C? Capital C. What's 40 plus 65? That's 105. Is that 75? Yes or no? Or am I doing this? 40 plus 65 is 105. Yes, 180 minus 105 is 75. Yes? Yes. All right. So now I know this. I already solved all the angles. So I do know that I'm going to do sine, or I'm going to do A, I'm going to C. You gotta, if this is a little a, this better be little c. So what goes here on top? I'm looking at this like that, or better yet, let me see. Let me erase. I'm looking at this. I'm doing like this, and then I'm going to go like this. So I'm doing A over sine 40, A over sine 40, and then I'm going to do what? Yes. And how do we get the A by itself? Well, or we can just multiply both. I'd rather do it like this. Sine of 40 degrees, get it done with. Sine of 40, and then put sine of 40 here. And that's all calculator work. So, hey, you better, I don't know what to tell you. You can get proficient with decimals. You can go ahead and use your phone. Or you come up and get a calculator here. which come up and get a calculator and make sure it's in degrees and learn how to get this answer. Well, how would you do this? I would go ahead and do 10 times sine of 40 in degrees, get an answer, then divide it by 75, sine 75. So this is going to be 10 times sine 40. No, I got this in rad. Got to change this to degrees. Okay, make sure it's in degrees, so it's going to get it wrong. So 10 times sine 40. Get an answer, divided by sine 75. Okay, what are you getting? To the nearest hundredth place. We just were in our meeting, our daily meeting, our Monday meetings, and we're just talking about just somebody came up with or was brought up about student not knowing how to round. All right. Anyways, so if I told you round to the nearest whole number, let me teach you some. What is that? 5th grade math? I don't know. Round to the nearest whole number. Anybody? What's the answer to the nearest whole number? 7 is correct. Round to the nearest 10th. 6.7. The 5 makes the 6 go up. Nearest 100th place. 6.65. Okay, you get it. Nearest 1,000th. How about nearest 1,000th place? 6.654. No, 5. 6.655. Yeah, makes it go up. In any case, to the nearest 100th is going to be 6.65. Let's go. Is that what I did? We go like that, like that. Make sure you keep them like 6.65, approximately 6.65. And now we can go ahead and do another one to figure out what this bottom one is. If this is, we called it capital C, this is going to be little c. So I would put on the top, I would put the C, what you're solving for. That's the way I would do it. So it's going to be C over, little c over sine, what? 65, sine 65. All right, let me go back. Just this is different than the way I have it on the PowerPoint. But I'm going to go with C over sine 65. And then don't use the one that has the approximation. Use the other one. Keep it with the one that is exact, more like this one. Yes, so I'm going to go 10 over sine 75. And then times both sides by sine 65 degrees. And then all calculator work, and then that would be it. Go ahead, put in the calculator. Get your calculators, give me an answer. What would it be? 10 times, 10 times sine 65. Get an answer, then divide that by sine 75. 9.38. Let's see. Who remembers doing this last year in geometry? No, you're like, if you don't like fully remember, you're like, then I guess not. Okay, so this is taught in geometry as well, supposed to, I guess. And we solved this non-right triangle. All right, let's see how much can we get. That's pretty easy. That I think. This is getting a little more weird. This ambiguous case. Yeah, we Okay, so we're going to solve this triangle. So you're not given a triangle. Well, you are given an angle and okay. Classify this triangle. Let's see. Before, okay, how do you classify this? This is A. Capital A would be here. Capital A. 54 degrees is something like it's an acute. It's a acute triangle. That would be a 90, like somewhere right like this, somewhere like right like this. Okay, that's gonna be 54. All right. As best you can draw a little more, I guess. And then we're saying that this is A, capital A. This is 54 degrees. Opposite of A is 13. So I decided to do it like this, where then I can draw that or connect those and make that equal 13 here. It's much harder when you don't have a triangle because you have to draw it. The homework's on top, I think, is it? We'll look for 8A. We're gonna go with being very. I use this as B, and this gotta be capital C. Both B capital C. So we don't have the angles, the other angles. We do have the other sides. No, not. We only got one other side. So we got the bottom. 15. 15. All right. So what kind of triangle? Classify this triangle. Anybody? It's okay. Just tell me, what do you think that this triangle is? Classify it. It is. This is not a side angle side. Yeah, some people are like, oh, look, well, it's a side angle side. No. You can't just jump anywhere. It's just, well, it would be if you wanted to, but that's not how we do it. It's you can't lift your pencil. You can't lift your pencil. Side. I don't know this angle here. I know this side, so it's a side angle. It's a side angle triangle. Or look, reading it backwards, what is it? It's not ambiguous. Is bad. It's bad. So it's not good. So it's gonna be difficult. This one. It's gonna have two solutions. Maybe two. Maybe one. Maybe zero. Is bad. Oh man, how are we going to solve it? How do we solve it? Well, we can solve it. We can solve it as it is. We can solve it. Can we solve for B? Can we solve for this angle B? Yes, yes we can. So it's going to be what? Let's go. Sine of what? Sine of B. Let's go. Let's go ahead and solve for this angle B. Sine of B over what? Come on, people. Sine of B over what? 15. Is going to equal to what? Well, what's the only other one that we do know? What is it? Sine of what? 54 over what? 13? So now, what's the next step in solving for B here? Yeah, everybody, come on. This is a little more complicated. How do we get this B, capital B by itself? What do I need to move first? Is it 15? Yes, 15. Multiply both sides by 15. Don't get confused. Usually we put it right here in the front, but it's okay. Cancel, cancel. I want to do this all at once, people. How do I get the B by itself? It's called the what? Sine inverse. We did this barely in the last unit, remember? So if you have sine B, to get rid of it, let me go step by step. Just go step by step. What we have right now is sine of an angle B is equal to, let me put that 15 right in the front. And then we got sine of 54 degrees over 13. Whatever. So now, To get the b by itself, we got to do the inverse of sine. The opposite, or opposite, multiply, divide, add, subtract, that kind of thing. Well, didn't we just do that? Didn't we do the sine inverse of this? We're gonna go and get the sine inverse of this, and then that's gonna cancel with the sine. And you do the same thing here. You gotta do a sine inverse of that. So basically, without writing all this out, you're gonna get b equals the sine inverse. Let me put it in here then, I guess. So it's gonna be sine inverse of this quantity. Now, the problem is knowing how to put this in a calculator. Get your calculator. Get your calculators and learn how to use this calculator, because that's what you're going to use for the test. Sine inverse. Let's go to degrees. We got degrees, sine inverse. Where's sine? Well, look for sine, but it's not going to be the sine. You're going to have to hit second sine. You see it? Yes, sine. Second sine. There's sine inverse. Then you're going to go ahead and do, hopefully it works, 15. Let's see if all at once it works. 15 times, yeah, it should work. 15 times what? Sine 54? The actual regular sine 54? Divide it, close it, because it's going to be, close it, and then divide it by 13. And close it again. What are you getting? Are you getting 68.98? I'm getting 68.98. Okay, so to what are we going to round? Okay, here's the question now. Are we going to round to nearest tenth, or nearest whole number? What are you going to do? What do I have in mind? Nearest whole number, I guess that's what I'm using right here. But on any kind of test, or any kind of my test, or any other kind of test, they better specify what they want. If they go like round to nearest tenth, nearest whole number, nearest whatever. I guess in this particular one, I have nearest whole number, 69 degrees. So basically now we got this 69 degrees is right here. Yep. So what's this bottom? What's going to be then C? Let's go. What would be C? Capital C angle. About. Come on, I think it's 180, no? Any triangle 180, so it's going to be 54 plus 69, take away from 180. Okay, so 57? Okay, 57. So if that is 57, okay, if this is approximately 57 degrees, then we can do again C over sine. We can go C over sine 57 degrees is equal to, and I will stick to the one that is given, that is not an approximation, 13 over sine 54. C over sine 57 degrees, 13 over multiply both sides by sine of 57 degrees. And then the calculator will do the work. Cancel, cancel. C is approximately whatever that is. 13 times sine of 57 degrees divided by sine of 54. What do we get? What do we got? I guess I did the nearest, what did I do? Nearest whole number, no? So what is it going to be? It's bad, I think. How the heck did I just round this thing? No, let's not round so much. What's nearest? That's going to be bad. So nearest tenth would be what? 3.5? 13.5? Let's see, what do I have? 13.5, yeah. Somewhat okay. Rounding to nearest whole would be it's going to be off by a lot. All right. So now why is this ambiguous? Why is this ambiguous? Here's the reason why it's ambiguous. I didn't have to draw it like that. I could actually make another triangle based off of the given information. I could have drawn it like this. Let me go back. I could have drawn it like this. I think you're gonna get the idea why you could have drawn it this other way. If this is 54 degrees still, it is 54 degrees. And I know that the opposite is 13, because this is A. The opposite is 13, and this is B. B, capital B is up there, so this is 15. I didn't, yeah, because that's capital B, this little b. I didn't have to draw it like this. I could have drawn it. I could have drawn it like this, and because this is the only one that's true. This is also true of what the length is. This is I already know what the length here is, but I didn't have to draw it like this. I could have drawn this angle. It's not set, so I could have drawn it like this instead. All right, here we go. I could have drawn it like this, and it would have made another triangle instead. If I would have drawn it like that. And the problem is to know this is going to be 15. So the problem is to know what it would be this angle here. And why would it be that? We could figure it out actually. What was it? Didn't we already do it one way? See the easiest way to do this? Let me see. Let's go. Let me show you. Well, we had this. I had drawn it like that. And we did get an angle of 69 degrees. Just subtract that 69 degrees. It will be this angle here. Look, watch. If this is a straight line, this whole thing is 180. So what is this? This would be the angle here of this. Of this is going to be this. So what's 180 minus 69? That angle here, that is going to be this. So go ahead and get your calculator. What's 180 minus 69? What is it? 111? Is it? So yeah, everybody, this is it. The other one, if you redraw it, and it'll create this, and then you create another triangle. That's why it does create two triangles. So if this is 54, this is 111, this would be 15, and then do the whole law cosines thing to get the rest of it. And that is it. That is it for today. Let me give you the worksheet. And that is it. Here we go. So let me stop this already.